What if the secret to Earth's oceans, and even the spark of life itself, wasn't found on our planet at all, but hidden inside a frozen traveler that's been drifting through space since the birth of the solar system? This is the story of Rosetta and Philae, the first mission to chase down a comet, land on it, and unlock its billion-year-old secrets. And what they found was nothing like we expected. For most of history, comets were feared. Ancient cultures called them broom stars or omens of war. Even in 1910, people panicked that Halley's comet's tail would poison Earth's atmosphere. But to scientists, comets aren't threats. They're time capsules. Unlike planets reshaped by volcanism and weather, comets have remained frozen for 4.6 billion years. Each one preserves the chemistry of the early solar system. Back in the 1950s, astronomer Fred Whipple described them as dirty snowballs, fragile clumps of ice and dust. But there was a bigger mystery. Could comets have delivered Earth's oceans, or even the chemistry of life itself? The early Earth was blistering hot, too hot for oceans to survive. So where did all that water come from? Some scientists argued it was comets. Others insisted asteroids. The debate split planetary science for decades. And then came the ultimate question. If comets carried organic molecules, could they have delivered the seeds of life? If so, comets weren't just ice and rock. They might be messengers of creation itself. But to know for sure, we'd need to do something humanity had never attempted. Land on a comet and see for ourselves. In the 1990s, the European Space Agency accepted the challenge. Their plan, Rosetta, a spacecraft designed to chase a comet for over 10 years, with a small lander called Philae. Together, they would attempt the first ever comet landing. From the start, fate threw obstacles in their way. In 2003, just months before launch, the Ariane 5 rocket meant to carry Rosetta failed on a different mission. ESA had to delay, and their original target comet was lost forever. A new target was chosen, 67P/Churyumov Gerasimenko. From here on, we'll call it Comet 67P. 4 kilometers across, shaped like nothing anyone expected. But the new orbit meant a brutal chase. Rosetta would slingshot past Earth 3 times and Mars once, stealing gravity with perfect precision. A single miscalculation, and it would miss the comet forever. The total journey, 6 billion kilometers. The most complex space chase ever attempted. And ESA made a bold engineering gamble. Unlike NASA, which often uses nuclear batteries, Rosetta would rely entirely on solar panels. No sunlight, no power. A single eclipse could kill the mission. But ESA pressed forward. On March 2nd, 2004, Rosetta finally launched. Its chase would last longer than most scientists' careers. By 2011, Rosetta had drifted so far from the sun that its giant solar wings couldn't keep it alive. The team had one choice: shut it down completely and hope it could wake up years later. So Rosetta was put into hibernation. Almost everything, heaters, transmitters, instruments, switched off. For 31 months, it drifted silently through deep space, kept alive only by a trickle of power to its brain. Imagine that. A $1.5 billion mission, 2 decades of work, left asleep and unmonitored. If it didn't wake up, everything was lost. On January 20th, 2014, ESA sent the wake-up call. Minutes dragged into hours. Engineers stared at silent screens. Some feared Rosetta was gone forever. And then, across 800 million kilometers, a faint signal returned. Rosetta had survived. Cheers erupted in mission control. The chase could continue. By August 2014, Rosetta finally arrived at Comet 67P. The first close-up images stunned the world. This was no snowball. The comet was shaped like a cosmic rubber duck, two lobes joined by a fragile neck. Its surface was scarred with cliffs, sinkholes, and shadowy pits. Jets of gas burst from the terrain like geysers. The dirty snowball idea was crumbling. This was a dark, jagged, alien world. Rosetta began mapping, while scientists debated where to drop Philae. The challenge? The comet's gravity was 100,000 times weaker than Earth's. One wrong bounce, and Philae could drift into space forever. November 12th, 2014. After a decade-long chase, the world held its breath. Philae, a lander about the size of a washing machine, was released from Rosetta and began its slow, 7-hour descent toward Comet 67P. Its mission: to anchor itself and begin months of experiments on the surface. To achieve this, engineers had armed Philae with 3 systems: a cold gas thruster to push it down, screws in its landing legs to drill in, and a pair of harpoons designed to fire instantly on contact. But hours before touchdown, the worst-case scenario hit. The thruster failed. Now Philae's fate rested entirely on the harpoons. At 15:34 GMT, a signal confirmed touchdown. For the first time in history, a spacecraft had landed on a comet. But within minutes, that celebration turned to confusion. The harpoons hadn't fired. The screws hadn't gripped. Instead of anchoring, Philae bounced. On Earth, bouncing sounds harmless. But on a comet where escape velocity is barely 1 meter per second, even a small jolt could fling a spacecraft into the void. Philae's rebound speed? 38 centimeters per second. Just slow enough to keep it bound, but fast enough to launch it nearly a full kilometer above the surface. For 2 agonizing hours, Philae tumbled through space. Engineers had no idea where it would land, or if it would land at all. By sheer luck, it struck the comet again, and bounced a second time. Finally, on the 3rd contact, the lander came to rest. Not at the carefully chosen landing site, but wedged awkwardly against a cliff wall, tilted and half in shadow. It had landed upright, a miracle in itself, but only one of its solar panels could catch sunlight. Instead of 5 months of operation, Philae now had just 60 hours before its batteries ran dry. Philae had no time to waste. Its instruments powered on immediately, racing to gather data before the batteries died. It deployed a drill to sample the surface, although at its tilted angle, the drill couldn't penetrate as intended. But Philae still managed to sniff gases, hammer the ground, and run its radar experiment through the comet's crust. For 60 frantic hours, the little lander worked against the clock. Then, on November 14th, 2014, its power ran out. Philae fell silent, slipping into hibernation in its dark resting place. Rosetta continued orbiting, dodging jets of gas and dust as 67P heated up near the sun. By summer 2015, the comet was releasing more than 300 kilograms of material per second. Then, against all odds, Philae stirred. In June, 7 months after its death, a weak signal reached Rosetta. Somehow the lander had survived the freezing darkness and recharged just enough to wake up. For a few brief days, it sent data, including results from its concert radar. which revealed the comet's interior was porous and brittle, stitched together like a cosmic sponge. But by July, contact was lost forever. It wasn't until September 2016, nearly 2 years later, that Rosetta's high-resolution images finally spotted Philae's resting place. Wedged in a crack, one leg sticking into the void. Only then could scientists put its precious 60 hours of data into full context. By late 2016, Rosetta itself was running out of fuel. ESA made a bold decision. The orbiter would join its lander on the comet. On September 30th, Rosetta began its slow descent, snapping breathtaking images of cliffs, boulders, and dust streams as it fell. These were the highest resolution comet pictures ever taken. Humanity's final postcards from 67P. And then, silence. After 12 years in space, Rosetta was gone. So what did those frantic 60 hours and Rosetta's 2 years in orbit actually reveal? First, Philae showed that the comet's surface was nothing like the fluffy, dirty snowball scientists expected. Its drill struck material that was hard as rock, solid water ice coated by dust. Because Philae bounced and ended up tilted, its drill never reached deep into the ground. But dust that clung to the lander itself gave clues. It contained 16 different organic molecules, 4 of them never seen before on a comet. These carbon-based compounds are the raw ingredients of life. Meanwhile, Rosetta had a longer window to study the comet from orbit. It collected over 30,000 dust particles blasted into space as the comet neared the sun. Surprisingly, their composition never changed, even as activity increased. This suggested the comet's interior was consistent all the way through, a pristine time capsule from the birth of the solar system. The dust was rich in carbon, mixed with metals like magnesium, calcium, and iron. But what stood out was the abundance of hydrogen and oxygen, signs that this material had remained cold and untouched since the solar system's earliest days. Rosetta also found something baffling: free oxygen in the comet's atmosphere. Oxygen is usually so reactive that it quickly binds into water or other compounds. The fact it remained free hinted at processes scientists still don't fully understand. Visually, 67P also shattered expectations. Instead of a bright snowball, it was darker than asphalt, reflecting only 3 to 4% of sunlight. Only small patches of exposed ice gleamed through the black, carbon-rich coating. And then came the biggest question of all: could comets have delivered Earth's water? To test this, Rosetta measured the ratio of hydrogen to its heavier isotope, deuterium, in the comet's water vapor. The result was clear. 67P's water didn't match Earth's oceans. That one number ruled out comets like 67P as the main source of Earth's water supply. But it didn't close the door completely. Instead, it suggested that while comets may not have brought Earth's oceans, they did carry complex chemistry, organics that could have seeded the building blocks of life. Even the comet's magnetic environment added another twist. At first, Rosetta detected a strange hum scientists thought was a magnetic field. But Philae showed there was no magnetism at the surface at all. Instead, the sound came from the solar wind interacting with the comet's thin atmosphere, creating a diamagnetic cavity, a region with no field at all. Together, these discoveries reshaped our picture of comets forever. Not just icy debris, but ancient, dark, chemically rich worlds, relics of creation that may have helped spark life itself. The Rosetta Philae mission transformed our understanding of comets. They weren't fluffy snowballs. They were rugged alien worlds. Their water didn't match Earth's, but their chemistry was rich with organics. And perhaps most importantly, the mission proved something deeper. Exploration is messy, unpredictable, and often doesn't go as planned, but it's always worth it. So the next time you see a comet streak across the sky, remember, you're not just watching ice and dust. You're watching a memory of creation itself.